Unit 3, Lesson 3, Energy. Big idea and essential question. The total energy of an object is the sum of its stored energy and energy of motion. Lesson 3, How does energy affect motion? Look at page 121. Objectives. I can observe and record changes of position. I can explain how to measure motion. I can compare the motion of various objects. I can describe how velocity and acceleration are related. Set a purpose for reading. Engage your brain. As you read the lesson, figure out the answer to the following question. Write the answer here. As we read through Lesson 3, think about this question. How would you describe the motion of the hummingbird in this picture? Turn to page 122 and read pages 122 and 123, Twisting and Turning. Let's review. Back and forth. Draw a picture of something that vibrates or moves back and forth. You might have drawn a picture of the pendulum of a clock, a waving flag, an electric toothbrush, or the strings of a guitar. These are some examples of things that vibrate or move back and forth. Name a part of the girl's body that is moving in several ways as she flips. She's moving her arms. The arms move up and out. Read pages 124 and 125. Fast or slow? Let's see how you did on Do the Math. Number 1, what is the speed of the rabbit during the race? We would do 100 meters divided by 10 seconds equals 10 meters per second. Number 2, what is the speed of the turtle during the race? That would be 5 meters divided by 10 seconds, which equals half a meter per second. Number 3, a chicken joins the race and runs at 4 meters per second. On the distance line, draw the chicken where it would be after 10 seconds. The chicken should be drawn with its beak lined up with the 40-meter mark on the distance scale between the turtle and the cat. Read pages 126 and 127. Pushes and pulls. Let's review these two pages. Why do you think workers spread sand on icy, snow-covered roads? The sand causes friction that keeps cars from sliding on the roads. Look at the truck, the force and the friction. The force of the road on the truck pushes the truck forward, and the friction, the snow exerts a force of friction that pushes backwards against the truck and slows it down. Look at the girl on the sled. Draw arrows and label them gravity, force, and friction. The arrow pointing down towards the girl should be labeled gravity. The arrow pointing away from the girl towards the boy is the force, and the arrow pointing the other direction from the girl is friction. Read pages 128 and 129. Changing it up, or changing it. Let's review these pages. Fill in the missing parts of the table. Let's start with the mouse. Its speed is 1 meter per second. It is suddenly chased by a cat. Would it have acceleration? Yes, it speeds up. The runner. Its speed is 8 meters per second. He runs at the same speed around a circular track. Would there be acceleration? Yes, because there is a change in direction. The train moves at 80 kilometers per hour. It moves along a straight track. Would there be acceleration? No, the velocity and the direction are constant. The jet plane moves at a speed of 300 kilometers per hour. What happens? He comes in for a landing or his speed slows. So is there acceleration? Yes, it slows down. Read pages 130 and 131. Let's review these pages. Which golfer would hit a ball that goes faster? Explain your reasoning in terms of potential energy and kinetic energy. Golfer A is holding his club higher with more potential energy. As he swings, potential energy is changed to kinetic energy, and the club moves harder and faster. So the ball will go faster and farther than the ball of golfer B. Read pages 132 through 133. Let's review these pages. At each point on the roller coaster, decide whether potential energy is greater than, less than, or equal to kinetic energy. Place the correct symbol in each box. A. Potential energy is equal to kinetic energy at position A. At point B, the potential energy is greater than the kinetic energy. At point C, the potential energy is equal to the kinetic energy. At point D, the potential energy is less than the kinetic energy. At point E, the potential energy is equal to the kinetic energy. And at point F, the potential energy is less than the kinetic energy. On which parts of the roller coaster would the car have the greatest speed? Why do you think so? The roller coaster car would be fastest at parts D and F because that's when the kinetic energy is the greatest. Turn back to page 121 to review lesson 3. Lesson vocabulary terms for this lesson were position, motion, speed, velocity, force, and acceleration. How would you describe the motion of the hummingbird in this picture? The wings are accelerating because they are changing their direction, or also their velocity. Complete sum it up on page 134. The directions say, read the summary statements below. Each statement is incorrect. Change the part of the statement in blue to make it correct. All right, guys, let's see how you did on Sum It Up. Number 1, you know that something is in motion when it changes its position. Number 2, to measure the speed of an object, you need to know how far it traveled and how long it took. Number 3, gravity and friction are two types of forces that act on objects. Number 4, an object accelerates when it speeds up, slows down, or changes direction. Number 5, when the potential energy of an object increases, the object's total energy remains the same.